Today, we are going on one of the biggest journeys imaginable. We're going to tell the grandest story in the universe, the incredible life and death of a star. From a fiery birth all the way to a galaxy-shaking explosion, this is a story that, believe it or not, connects all of us to the cosmos.
I mean, seriously, have you ever just looked up at the night sky and wondered, what are all those little lights? Where did they come from? And what happens to them when they burn out? Well, today we're going to answer that. We're going to trace their entire story, from a tiny whisper of gas to the most powerful explosions in the universe. So every story's got a beginning. And for a star, that story starts in a place that's chaotic, messy, and absolutely beautiful. A cosmic nursery. It all starts right here, inside something called a nebula. Think of these as the galaxy's maternity wards. They're just these enormous swirling clouds of dust and gas. And here's the crazy part. Every single star you can see in the night sky got its start in a place just like this. So how do you get from a simple cloud to a shining star? Well, the secret ingredient is gravity. Gravity just patiently starts pulling these clouds of dust and gas into bigger and bigger clumps. As all that stuff falls together, it heats up, and you get this glowing ball called a protostar. But gravity isn't done yet. Oh no. It keeps squeezing, acting like a giant pressure cooker. It squeezes that core, making it hotter and denser, until, bam! The pressure is so immense that nuclear fusion kicks in. And in that one brilliant flash, a star is officially born.
So after that dramatic birth, a star settles down for a long, long time. This is its adulthood, the most stable part of its life. And it's exactly where our own sun is right now.
You know, the key to a star's long life is all about balance. Deep down in its core, you've got nuclear fusion creating this massive outward push. It's constantly trying to blow the star apart. But at the exact same time, the star's own gravity is trying to crush it. When those two forces are perfectly matched in this epic cosmic tug of war, the star is stable. We call this the main sequence. And this stable period, it's not short. We're talking billions of years. Our sun has been chilling in this phase for almost 5 billion years, and it's got about 5 billion more to go. It's actually this incredible stability that gave life here on Earth the time it needed to get started. But, you know, nothing lasts forever. When a star starts to run out of fuel, it reaches a fork in the road. And what happens next? Well, it's all decided by just one thing: how big it is. Yep, a star's mass is its destiny. See, all stars eventually run out of hydrogen, their main fuel, but how they die is totally different. Smaller stars, kind of like our sun, they puff up into what's called a red giant, and then they just sort of fade away. But the real heavyweights of the galaxy, the ones that become red supergiants, whoa, their end is way more violent and, honestly, way more spectacular. Okay, so let's follow that first path, the one for stars like our sun. Their ending isn't really a bang, it's more like a beautiful, slow fade to black.
So as a red giant, the star gets really unstable and eventually just poofs its outer layers off into space. What's left behind is this small, super hot, super dense core called a white dwarf. This thing will keep shining for billions of years, but eventually it will cool down and fade out, becoming a cold, dark black dwarf, just silently drifting through space forever.
All right, let's go back and take that second path, the one for the real monsters of the cosmos. Their end is no gentle fade. It is the single biggest fireworks show in the entire universe. As a red supergiant, the star's core is like a cosmic forge, creating heavier and heavier elements. But it can't keep that up. Eventually, the core can't fight against its own weight anymore, and gravity wins. In less than a second, the core collapses, and that triggers a shockwave that just rips the entire star apart in this unbelievable explosion. And that event is called a supernova. A single supernova can be brighter than its entire galaxy for a short time. It releases more energy in an instant than our sun will in its whole 10 billion year life. Just think about that. So what happens after this insane explosion? Well, the supernova blasts all those heavy elements, we're talking gold, oxygen, everything, out into space. This is the raw material for new stars and new planets. But right at the center of the explosion, the crushed core of the star keeps collapsing, and it's about to become one of two of the absolute weirdest objects in the universe. And what it becomes all depends on how massive that star was to begin with.
If it was pretty big, say up to 20 times the mass of our sun, its core gets crushed into a neutron star. This thing is so dense that a single teaspoon of it would weigh more than Mount Everest. But if the star was even more massive, then gravity just becomes unstoppable. The core collapses forever and literally tears a hole in space and time itself. It becomes a black hole. A black hole is basically gravity's final boss. The core collapses down to a point of infinite density, creating a gravitational pull so strong that not even light can escape it. Nothing that crosses its border, the event horizon, can ever get out again. And that's why it looks like, well, a perfect black hole in space. So what's the big takeaway from all this? It's that this whole cosmic cycle of birth and death is the reason we're even here. The iron in your blood, the calcium in your bones, all of it, it was cooked up in the heart of a star that lived and died billions of years ago. We are, and this is literally true, made of stardust.